In the summer of 1928, something small happened in a cluttered laboratory in London, something so tiny, so seemingly insignificant, that it could have been dismissed as nothing more than a nuisance, a contamination, a mistake. But that small accident would become one of the most important moments in the history of medicine. It would save more lives than any war has ever taken. It would change the very nature of human existence on this planet. And it all started because someone forgot to clean up before going on vacation. Picture London in the late 1920s. The Great War had ended just a decade earlier. The world was still counting its dead. Millions of young men had perished, not just from bullets and bombs, but from something far more insidious. Infections, simple wounds that became death sentences, a scratch that turned gangrenous, a cut that led to sepsis. The medical community watched helplessly as soldiers died not from their injuries, but from the invisible enemies that invaded those injuries, bacteria, microscopic killers that no one knew how to fight. In this world lived Alexander Fleming, a Scottish bacteriologist working at St. Mary's Hospital in London. He was not a neat man. His laboratory was famously chaotic, cluttered with petri dishes and cultures and experiments in various stages of completion or abandonment. Some called him careless. Others called him brilliantly distracted. But on one particular day in August 1928, his messiness would prove to be the most fortunate accident in medical history. Fleming had been studying Staphylococcus bacteria, trying to understand these dangerous microorganisms that caused so many deadly infections. Before leaving for a vacation in Scotland, he stacked several culture plates on his lab bench. He did not sterilize them, he did not properly store them. He simply left them sitting there in the warm London air, near an open window. It was the kind of oversight that would make any modern scientist cringe. But sometimes the universe rewards carelessness with miracles. When Fleming returned weeks later, he began examining his cultures. Most were contaminated, ruined by mold spores that had drifted in through that open window. He prepared to throw them away, trash, failed experiments. But then something caught his eye. On one particular plate, something strange had occurred. Around one area of mold growth, there was a clear zone, a circle of nothing. The bacteria that should have been growing there had simply vanished. They had been killed, destroyed, dissolved by something the mold was producing. Fleming stared at that plate. He could have dismissed it, could have thrown it away with the others, could have considered it just another contamination in a messy lab, but he did not. He recognized that he was looking at something extraordinary. The mold, which he identified as belonging to the Penicillium genus, was secreting some substance that killed bacteria. He called this substance penicillin, and in that moment, though he did not fully realize it yet, he was holding the future of humanity in his hands. But here is where the story becomes frustrating, maddening even, because Fleming published his findings in 1929 and almost nobody paid attention. The medical community largely ignored his discovery. Fleming himself struggled to purify penicillin, to concentrate it, to make it stable enough for medical use. He found it extremely difficult to produce in meaningful quantities. Within a few years, he had largely abandoned his research on it. That miracle sitting in his laboratory remained just an interesting observation, a footnote, a curiosity. The tragedy continued. Throughout the 1930s, people kept dying from infections that penicillin could have cured. Children died from scarlet fever. Young mothers died from childbed fever. Men died from infected cuts. The cure existed. It had been discovered. But it sat unused, forgotten, gathering dust in medical journals that almost no one read. Then came 1939, and the world plunged into another devastating war. The need for antibiotics became desperate, urgent, critical. At Oxford University, two scientists named Howard Florey and Ernst Boris Chain stumbled upon Fleming's old papers. They recognized what Fleming had found, they understood its potential, and unlike Fleming, they had the resources and the chemical expertise to purify penicillin and produce it in quantities that could actually treat patients. In 1941, they conducted their first human trial. A policeman named Albert Alexander had scratched his face on a rose thorn. That tiny scratch had become infected. The infection had spread throughout his body. He was dying slowly, in agony, his body consumed by bacteria. The doctors gave him penicillin, and something remarkable happened. Within 24 hours, his fever dropped. His condition improved dramatically. For the first time in human history, doctors watched as a deadly bacterial infection was stopped in its tracks. Unfortunately, they ran out of penicillin before they could complete his treatment, and Albert Alexander died. But they had seen enough. They knew penicillin worked. The race was on. The American and British governments recognized that penicillin could save countless soldiers' lives. They poured resources into mass production. By D-Day in 1944, there was enough penicillin to treat every Allied soldier who needed it. For the first time in human warfare, more soldiers survived their wounds than died from them. Infections that would have been death sentences became treatable conditions. The difference was staggering, profound, revolutionary. But the impact went far beyond the battlefield. After the war, penicillin became available to civilians. Suddenly, diseases that had terrorized humanity for millennia became curable. Pneumonia, meningitis, syphilis, scarlet fever, bacterial endocarditis, septicemia. The list goes on and on. Mothers stopped dying in childbirth from infections. Children survived illnesses that would have killed them just years earlier. Simple surgeries became safe because post-operative infections could be treated. The numbers are almost incomprehensible. It is estimated that penicillin and the antibiotics that followed have saved over 200 million lives. 200 million human beings who would have died but did not. 200 million futures, families, dreams, contributions to humanity, all because of a contaminated petri dish in a messy laboratory. Think about that for a moment. If Fleming had been a tidier scientist, if he had properly cleaned and stored his cultures before vacation, those mold spores would never have landed on that plate. If he had thrown away that contaminated dish without examining it closely, the discovery would have been lost. If Florey and Chain had not happened to read his obscure paper a decade later, penicillin might have remained forgotten even longer. The entire course of human history balanced on these incredibly fragile coincidences. And it changed more than just medicine. Penicillin fundamentally altered human society. It enabled the population boom of the mid-20th century. It made modern surgery possible. It allowed people to live long enough to develop the chronic diseases we now struggle with, like cancer and heart disease, because they were not dying young from infections anymore. It changed our relationship with the microbial world. We went from being helpless victims of bacteria to having weapons against them. Standing in the 21st century with all our advanced medical technology, it is almost impossible to imagine the world before antibiotics, a world where a paper cut could kill you, where strep throat could be fatal, where childbirth was one of the most dangerous things a woman could do, where doctors could diagnose your infection perfectly but had nothing to offer except hope and prayer. That world existed less than a century ago, and it ended because someone left a window open and forgot to clean up their lab bench. The butterfly effect is not just about chaos theory or time travel stories. It is real. It is happening all around us. Small actions, tiny moments, seemingly insignificant choices that ripple outward and change everything. Fleming's discovery reminds us that history is not just made by kings and presidents and generals. It is made by curious scientists examining contaminated plates, by researchers willing to follow up on forgotten papers, by governments willing to invest in strange mold extracts that might save lives. Every life saved by antibiotics in the past 75 years traces back to that messy laboratory in London. Every person who survived an infection, who lived to have children, who contributed something to the world, exists downstream from that August day in 1928. You might be one of them. Someone in your family almost certainly is. We are all living in the world that Fleming's carelessness created. So the next time something seems small or insignificant, remember this story. Remember that the greatest medical discovery in history began with an accident, with a mistake, with something that looked like failure. Remember that one contaminated plate, examined by one curious mind, cascaded into 200 million lives saved. Remember that the smallest causes can have the most profound effects. And maybe, just maybe, pay attention to the accidents and coincidences in your own life, because you never know which small moment might change everything. If this story made you think differently about history, about science, about the power of small moments, hit that like button. Subscribe to see more stories of tiny events that transformed our world, because history is not just about the big moments. Sometimes it is about a forgotten petri dish that saved humanity. And there are so many more stories like this waiting to be told.